Hello everyone. Today we are going to discuss a very important topic of data analytics, that is Hadoop. Myself, Rupali Chore. I'm working as an assistant professor in SIRT College, Bhopal. So let's start. As to understand what exactly is Hadoop, we have to first understand the issues related to big data and the traditional processing system. So advancing ahead, we will discuss what is Hadoop and how Hadoop is a solution to the problems associated with big data. So let's start. In our previous videos, we have already discussed about big data in detail and the challenges with the big data. In this video, we are going to discuss about the problems with traditional approach, evolution of Hadoop, Hadoop as a solution, and when should we use the Hadoop. So let's start. Hadoop as a solution for big data. Here we can see that big data as an opportunity. Big data is emerging as an opportunity for organizations. Now organizations have realized that they are getting lots of benefits by big data analytics. As you can see in the image, they are examining large data sets to uncover all the hidden patterns, unknown correlations, and market trends, customer preferences, and other useful business information. So these analytical findings are helping organizations in more effective marketing, new revenue opportunities, better customer service. So they are improving operational efficiency, competitive advantages over rival organizations, and other business benefits. So let us move ahead and know the problems associated with the traditional approach in encashing the big data opportunities. So problems with traditional approach. In traditional approach, the main issue was handling the heterogeneity of data. It means that the data was structured, unstructured, semi-structured, but the RDBMS always focuses mostly on structured data like banking transactions, etc. And Hadoop specializes in semi-structured, unstructured data like text, video, audios, Facebook posts, etc. In RDBMS technology, it is proven highly consistent, matured systems supported by many companies, while on other hand, Hadoop is in demand due to big data, which mostly consists of unstructured data in different formats. So let us understand what are the major problems associated with big data. So moving ahead, we can understand how Hadoop emerged as a solution. The first problem, as you can see in the image, associated with the big data is the storage. Storing this huge amount of data in traditional system is not possible. The reason is obvious. The storage will be limited only to one system and the data is increasing at a tremendous rate. So second problem associated with big data is storing heterogeneous data, as we discussed already. Now we know storing is a problem, but let me tell you, it is just a part of a problem, since we discussed that the data is not only huge, but it is present in various formats as unstructured, semi-structured, and structured data. So you need to make sure that you have a system to store all these varieties of data generated from various sources. Okay, and now next, the third problem associated with big data is accessing and processing of that big data. The hard disk capacity is increasing day by day, but the disk transfer speed or the access speed is not increasing at similar rate. Let me explain you this with an example. If you have only 100 Mbps IO channel and you are processing 1 terabyte of data, it will take around 2.9 hours. So now if you have 4 machines with 1 IO channel for the same amount of data, it will take 43 minutes approximately. Okay, so accessing the big data and processing speed is the bigger problem than storing the big data. Before understanding what is Hadoop, let us first look at the evolution of the Hadoop over the period of time. So in 2003 and 2005, Cutting launches Project Nudge to handle billions of searches and indexing millions of web pages. Later on, in October 2005, Nudge used GFS and MapReduce to perform operations. Now, you would be surprised if I would tell you that in 2007, Yahoo started using Hadoop on a 1000 node cluster. So later on in January 2008 or something, Yahoo released Hadoop as an open source project to Apache Software Foundation. You can see here in the image. In 2009, Hadoop successfully sorted a petabyte of data in less than 1 hour to handle billions of searches and indexing millions of web pages. And in December 2011, Apache Hadoop released version 1.0. Later on, in August 2013, version 2.0.6 was available. So when we were discussing about the problems, we saw that the distributed system can be a solution and Hadoop provides the same. So let us understand what is Hadoop. Hadoop is a framework that allows you to first store big data in a distributed environment and different methods to process it parallelly. There are basically two components in Hadoop, HDFS and MapReduce, as you can see in the image. The first one is HDFS, which is used for storage, and it allows you to store data of various formats across the cluster. The second one is YARN, and which is resource manager of Hadoop. It allows the parallel processing over the data. And MapReduce programs are the basic building blocks of Hadoop, which allows the parallel processing of data stored in the HDFS. So let us first understand what is HDFS. HDFS creates an abstraction. Let me simplify it for you. Similar as virtualization, you can see HDFS logically as a single unit for storing big data. But actually, you are storing your data across multiple nodes in a distributed fashion. As you can see here, there are multiple nodes and there is a single master node also. In HDFS, name node is the master node and the data nodes are the slave nodes. Name node contains the metadata about the data stored in the data nodes, such as which data block is stored in which data node, or where are the replications of data block kept, etc. The actual data is stored in data nodes. I also want to add here, we actually replicate the data blocks present in data nodes, and the default replication factor is 3. Since we are using commodity hardware and we know the failure rate of these hardwares are pretty high, so if one of the data nodes fails, HDFS will still have the copy of those lost data blocks. You can also configure replication factor based on your requirements. So you can go through HDFS in our upcoming videos. So how Hadoop provides a solution for our problems here. Let us understand how Hadoop provided a solution to the big data problems that we just discussed. The first problem is storing big data. HDFS provides a distributed way to store big data. Your data is stored in blocks across the data nodes, and you can specify the size of blocks. Basically, if you have 512 MB of data and you have configured HDFS such that it will create 128 MB of data blocks, then to store it across different data nodes, it will also replicate the data block on different data nodes. Now, as we are using commodity hardware, hence storing is not a challenge. It also solves the scaling problem. It focuses on horizontal scaling instead of vertical scaling. You can always add some extra data nodes to HDFS cluster as and when required. So instead of scaling up the resources of your data nodes, let me summarize it for you. Basically, for storing 1 terabyte of data, you don't need a 1 terabyte system. You can instead do it on multiple 128 GB systems or even less. Okay, so the next problem was storing the variety of data. So with HDFS, you can store all kinds of data, whether it is structured, semi-structured, or unstructured. Since in HDFS, there is no pre-dumping. Sorry. So with HDFS, you can store all kinds of data, whether it is structured, semi-structured, or unstructured. Since in HDFS, there is no pre-dumping schema validation. And it also follows write once and read many model. Due to this, you can just write the data once and you can read it multiple times. Okay. So third challenge was processing. Third challenge was accessing and processing data faster. Yes, this is the one and the major challenges with big data. In order to resolve it, we move processing to data and not data to processing. What does it mean? Instead of moving the data to the master node and then processing it, in MapReduce, the processing logic is sent to the various slave nodes, and then the data is processed parallelly across all the slave nodes. Then the processed results are sent to the master node, where the results are merged and the response is sent back to the client. So in YARN architecture, we have resource manager and node manager. Resource manager might or might not be configured on the same machine as main node, but node managers should be configured on the same machine where the data nodes are present. Okay. So thank you very much, friends, for listening patiently. In our next video, we will discuss about the reading and writing mechanism of HDFS. So stay tuned, keep learning. Thank you very much.